Anybody have any questions before we get started? Waiting for a few more people to jump on. Did anyone have any ideas or topics they want to talk about next week? All right, well, we could think about it. I think we'll have less people this week because some people moved over to that 100-ton class, but we should still have more people than 16. We'll give it a few more minutes here.
They're all out drinking and celebrating the women's national soccer team victory.
Ooh.
I have a question.
Yeah, go ahead.
How do you, is there any way to try to predict like fog in your path, or is it just kind of one of those unpredictable things?
Weather prediction, there are great weather predictions, specifically maritime weather prediction and even sailing weather maritime prediction websites that it depends, you know, if you're sailing to Hawaii, do you have access to those or not? I mean, you could predict out as much as you can using those types of, but those will have, you know, a prediction of fog. Of course, you can get fog when it's not predicted to have fog, but they will show all sorts of different things on the weather maps.
Okay.
Does anybody have a weather site that they like to use specifically for sailing?
Windy.
Windy. Yep, Windy. Sail WX is another one a lot of people use. There's always, you know, the NOAA NHC.
I like Sail Flow too, just for seeing the big picture and all the
Sail
full
Flow?
patterns. It shows all the arrows and all. It's really on an iPad at least.
Colorful picture.
Yeah.
Sail what?
Sail Flow.
FLOW or FLO?
FLOW. It's not good on a phone. Nothing's good on a phone because it's so small, but the iPad is a nice,
Yeah.
looks really good on the iPad.
What is the other one? I think Sail Passage is another one. Oh, Passage Weather. That's what it is. Sorry.
I just use the one that's on U.S. power boating, the buoy.
Yeah. All right, well, let's get started. I don't know where everybody is tonight, but that's okay. Let's see. Well, so last week we did our visual fixes with 2 or 3 lines of position. And this week we are going to work on 2 more types of fixes that are very similar, but just tweaked a little bit, that we can use out there. And we're going to practice during our lecture. And then we're going to do, so assignment 13 kind of during our lecture, and then assignment 14 will be our homework. Hopefully we'll get through at least the first page of that today. And then next week is our final week. So I know hopefully you guys have the final assignment in your packet. The final is really just kind of a review of every homework assignment we've done. So it's a great little refresher. And usually I do it with everybody in class, but I posted the video and I feel like people like the video because they can rewind if they want to see a part over again. So so next week I really don't have any new subjects. We can review a little bit of the final and go over any questions or any other topics you guys might have. Feel free to email me some. I'll put a little PowerPoint or something together. And then for those of you interested in CoNav1, we're going to be talking about set and drift, currents and tides, and a little bit about GPS. But for those of you who are interested in electronic navigation, that actually starts after CoNav1. So March
But it's unfortunately already full.
Oh, it's already full?
Yeah.
Oh.
As well as the next one also is already full.
Oh, wow. Okay. I was going to say, that's a good one to add on to this class, but it's already full. Okay. I'm not teaching that one. That one is in person partly, and I am doing online for the time being until things get better in the world. Anyways. Okay. Let's see.
Bree,
Yeah.
just to clarify, it is the final, I have 3 pages. Is that correct? Is it 3 or just make sure I'm not missing anything?
Correct. It's 3 pages.
Okay, cool. Thanks.
Okay. Sorry, I'm adjusting my screens here. Can you guys see the PowerPoint screen? That's what you're looking
Yes.
at, right? Okay. Okay. So we're going to be doing a bow and beam fix, a running fix, and then we're going to talk about danger bearings. So I have a tendency to concentrate on the first 2 things and then like forget about the danger bearings. So if I don't talk about danger bearings by the end of class, somebody shout at me and tell me to talk about those. I have a little post-it on my computer screen so I can remember, but I get distracted. Okay. First, we'll talk about a bow and beam fix. Now, I guess I wish I added a new slide. I'm actually going to stop the share here. And add in a slide. Sorry. If we can remember back to week 2. Not week 2. Sorry, bear with me for a second. Okay, share screen. Okay. So we're looking at the PowerPoint again, right? Okay, cool. Okay, so I kind of did this little hierarchy of types of fixes back on whatever last week or the week before. So we had talked about dead reckoning, and remember that is an old position, and then it's purely calculated. It's just what we think our course is and what we think our speed is, and we create a vector. That's a dead reckoning position. So it's just this calculated position. And then we have, I'm going to put in here our bow and beam fix, and that's what we're going to talk about today. So it's a little bit better, a little more accurate, more information than a dead reckoning fix, but it's not quite super reliable, I guess I'm going to say. It's lower on our rankings. And then we have an estimated position, which is a dead reckoning plus one piece of information, whether it be a one LOP or set and drift or one extra piece of information. And then our running fix is two lines of positions at different times, which we're going to talk about today. And then we have the electronic fix, which is going to be our GPS, and we know how to plot the Latin long from GPS or radar. And then we have our visual fix, which we worked on last week. So I just want to keep this in the back of your head. Sorry. Keep this in your back of your head as we are talking about them, these types of fixes this week. So our bow and beam fix is just a little bit better than dead reckoning. Then we have the estimated position, and then we're going to have the running fix. Okay, so let's get into a bow and beam fix. We're going to go back to Billy's classroom here and talk about geometry and the isosceles right triangle. So the isosceles right triangle is a triangle that has a 45, 45, and a 90-degree angles. So that means if we're looking at a triangle, a right triangle means we have a right angle, a 90-degree angle in that triangle. And then if we have the same angle on our other two triangles, that's called an isosceles triangle. So the same iso. Also known as the 45, 45, 90. But the theory behind this is if this angle, the 45 at B and 45 at A are the same, then the length of the B to C and A to C are the same. So if these angles are the same, then the lengths of those sides of the triangle are same. So if we give, our sailing navigation vocab to this triangle, then we could make it beneficial for us. So if we say, I'm gonna skip okay, so this is my example. My example is A is a light. So it's a specific light that we can see. And we are gonna start at point B. And if we see that light at exactly 45 degrees off the bow, so that's, depending on what we have on board, we can say, oh, it's right off the bow right there. And then however long it takes us, we can say, oh, it's bearing directly on the beam. So we saw it on the bow, 45 degrees on the bow, and then we saw it exactly on the beam. That's 90 degrees from your heading, exactly on the beam. So if we saw something on the bow and then the beam, the distance run between those two times is equal to the distance off. And then we could use that distance off as an LOP. So let's look at this on the next slide. So in this scenario, our distance run from our point B to point C, from when it was off the bow to when it was off the beam, is equal to our distance off. So if we can calculate using our 60D street how far we would have traveled in the time period of when we saw it off the bow to when we saw it off the beam, that would be our distance run. And if it's this isosceles right triangle, our distance run is equal to our distance off. And then we could use that distance off for an LOP range, and we can get a fix at this specific time of when we saw it on the beam. So let's look at an example of this before we get really confused. Well, first, I guess we're going to go on our steps. So our first step is to note the time when the object is broad on the bow. So that's 45 to starboard or 45 to port. So we're just going to note that time. We're not actually taking a bearing because we don't really have something that tells us something is 45 degrees off the bow. Maybe you have a structure on board. Maybe you have something that can help you. But this is where that wiggle room of this kind of like quick and dirty fix comes in, right? Like we're just marking the time of when that object is on the bow, 45 degrees one way or the other. And then we maintain our course and speed, and then we're going to note the time when it's exactly on the beam. Again, we're eyeballing it, right? We're just saying, yep, it's on the beam now. I'm going to note that time. And then we use our 60D street to calculate our distance run, which will be equal to our distance off. And then we plot the LOP. So let's keep having more things on the slide. Pro tip, use a structure on your boat to get a bearing perpendicular to the center line, like the end of the cabin, the forward end of a cockpit, a pair of winches, whatever it is. So here's an example. We are headed due north. So we're using our same triangle here. We're headed due north at a speed of 10 knots. At 6 o'clock, we see the lighthouse bearing 45 degrees on the bow. And then at 6:30, we see it exactly on the beam. So we have traveled 30 minutes. That's our time difference here. So we're going to put that into our 60D street and calculate our distance. So our speed was 10. It took us 30 minutes to go from the bow to the beam. And we get a distance of 5 nautical miles. So then we could plot this. Let's go to my plot. So first we want to plot our line. So I use that R plus S equals T. That's that relative bearing formula. But if you already have plotted a DR line on your chart, you don't need to do this because it's super easy just to put the triangle on your chart and you get a perpendicular line. So if you already have plotted, hopefully you've plotted a DR or your track line somewhere along the way, you can just use that line. But for this case, the bearing of this lighthouse would be 090. that it is bearing 090 from me. So I'm just going to draw that 090 line. So again, when we do this on the chart, it's going to be a lot easier because we just have, we already have our track line or DR plot line there that we can use. And then we're going to use that distance off, or distance traveled equals distance off, as our second LOP. So this 090 LOP tells us we're somewhere along this line, but we don't know where. Then I measure my 5 nautical miles and I swing an arc to say that is my 630 position. So I have 2 LOPs. I have my distance off and the bearing at 90 degrees. And that's going to be my bow and beam fix. So
You lost me at 90.
at this RST,
Yeah.
okay, so R is relative. It is 90 degrees relative to starboard or port. So 90 degrees relative. Our ship's heading is 000. So R plus S, so 90 plus 0 equals true. But this will make more sense when we put it on the chart. I wish I just didn't have that. R plus S equals T. That always confuses people. Let's do it on the chart. It will make more sense. So let's get out assignment 13 and let's do it on the chart together. Can you guys see the chart now, right? Hope so. Okay.
The R plus S plus, I'm sorry, the R plus S equals T, is it relative bearing or is it relative heading?
Relative bearing plus your ship's heading.
Okay, thank you. And that gives you the true
Bearing.
bearing. Got it, thank you.
Okay, so let's make sure. So for assignment 13, our bow and beam, we're going to plot our 12 o'clock position. I've tried to make it a little bit easy for us. We're along this, we're along this latitude line. So 33 degrees, 30 north, and then 118, 26.1. So here is my 12 o'clock, and they told me I'm on a course of 115 at 7.2. So I'm going to put my pencil on the 12 and find 115. I have a course of 115 and a speed of 7.2. So I'm going to give you guys a minute. So just plot this. Don't plot anything else just yet. Just plot this information. Well, why don't Okay, so if you guys want me to slow down, I will, but I'm just gonna keep going here. So we have a 12 o'clock position, and we are just continuing on our course of 115 at 7.2 knots. And then I have noted, I see long point down here. This is going to be a distinct point that I can see. So I'm going to note when this is broad on the bow, so 45 degrees relative, but we can just call it broad on the bow. And then when is it broad on the beam? So I've just made a note in my logbook. I haven't like plotted anything. I just made a note that at 12:16 it was about broad, and then at 12:46 it was exactly on the beam. So now I want to plot my bow beam fix. I have my 2 times. That's what I need. My two times. So I go to 60 D Street. Or first I need the time, right? So we have 12:46 minus 12:16 gives me 30 minutes. So I go to my 60 D Street, and I'm looking for the distance traveled, because distance traveled is equal to distance run. So I'm looking for my distance traveled in 30 minutes. So distance equals S times T divided by 60. So I have my speed of 7.2, right? That was my speed, 7.2, times my time of 30 minutes divided by 60. What is my distance run?
.6.
3.6 nautical miles. So my distance run is equal to my distance off. So I'm going to use this and that it was off the beam to get my 12:46 position. So how I'm going to do that, I already have this course line plotted. So I am going to put my triangle so that I have 90 degrees on either side. So that's putting this, this 90-degree line of my triangle, this perpendicular line, kind of this one on the center, over my course line. So I'm just lining up the lines. I'm not actually like measuring anything. I'm just lining up the lines.
And that has nothing to do with the light.
Yes, it will. Yes. I'm just
No,
showing
no,
you how-
I mean, you're not lining up the bottom corner with the light. You're just making sure it's perpendicular.
So I'm going to make it perpendicular. So as I'm traveling, here's my little boat. As I'm traveling, right? Anything that I see perpendicular is going to be somewhere along this line. So I am going to wait till it gets to my long point, that specific light, and make sure that that middle line is lined up on my track line. So it looks like that. And I'm going to say I'm somewhere along this line. That is an LOP for 1246. I'm somewhere along that line. But because I noted in my little notebook or my logbook, when that object was off the bow, 45 degrees, I can also get a second LOP. And that second LOP is going to be our distance off LOP. Distance off is equal to distance run. So my distance off was 3.6. So I'm going to go over and find 3.6 nautical miles 123.6. 3.6 nautical miles. That was my distance run, but it is also equal to our distance off. So I'll put that from my long point, my distance off. Did I get 3.6? 2, 3. I did. I have a feeling I messed up somewhere. Oh my gosh, my position's wrong. That's what it was. Anyways, who cares about the position? This would be my 1246 bow beam fix. Yours is going to look different than mine because I plotted this position incorrectly. That is my bad. 26.1. I was like, this should line up. This is your 12 o'clock position. Did anybody see that my position was incorrect? Why didn't you holler at me?
I thought I was going crazy.
No, that's me.
Well, I had drawn something else wrong, so I wasn't figuring it out until you were saying it.
There we go. But it's the same concept there. I just made an error in my plotting, which happens to the best of us, right? But we were on the same course, so it really didn't really affect where our 1246 position is. So when we talk about a bow and beam problem, we are, making that assumption that at exactly 12:16, it was 45 degrees off the bow. Maybe it was 12:17, maybe it was 12:15. Those different times can just make a little bit, tweak it here or there. So that's why I put this fix at the kind of at that it's better than a DR, but it's not quite like an estimated position or electronic fix. We're not going to put that much weight into it because they are assumptions of it's at the 45 and it's at the beam. If we have an instrument to actually measure the 45 and the beam, then great, we can make it. But I really don't know what you would use to get that 45 besides just, your vision, your instinct, your intuition, whatever you want to call it. What kind of questions do you guys have with the bow and beam fix? Does this make sense? Okay, so it's just this kind of quick and dirty way to get a quick fix to see if we're, to the right or left of course. Do we need to make some adjustments?
I have a question.
Yeah, go ahead.
From 12 o'clock to 12:46 on our CSE, are you measuring 3.6 nautical miles from those 2 points?
No, I did not measure. I did not plot my 12:16 fix. I only plotted my 12:46 fix.
Okay.
You can plot the other one. And in this case, it will work out to that perfect triangle. But
Yeah, that's what I did. I plotted it for some reason, I plotted it from 12 to 12:46, not 12:16. I don't know, I must have read the question wrong.
So the question kind of walks you through it. I don't really like how the question is phrased. It really walks you through it, kind of like proving how this works. But the whole point of this is to be this like quick and dirty fix that you just mark a time. You didn't plot anything. You just said, oh, it was on the bow at 12:16, and then it was on the beam at 12:46. Now I'm just going to quickly put a position down. So it's eliminating like, oh, I have to plot the 12:16 and then like advance it, whatever, and then plot the 12:46 and then do this thing. So it's the whole point of this bow and beam fix is to just quickly get an estimate of where you are. Does that make sense? So it's not like this super accurate thing that I want you to be like stressing out about, like, oh, my isosceles triangle isn't perfect or something. It's just this, I don't know, rough fix. I hope that makes sense.
It's very cool.
Okay. Okay. We're gonna move on to the running fix. But in our assignment that we're gonna do tonight, we are gonna do another bow and beam and running fix. So we will get more practice on this. But I just wanted to go over it here. Okay.
I'm just a little bit confused as to why we're getting the 45 degrees off of 12 and not 12:16. I mean, from 12 to 12:16, you could have changed course.
So we are assuming that we are maintaining course and speed, just like a DR, you know, we're assuming we're maintaining course and speed this entire time. So we are, you know, taking on those assumptions that
12:16.
our course hasn't changed. The 12 o'clock fix and course line is just to give us a, you know, a plot of where we are, kind of a baseline, a starting point. And then at 12:16, we were somewhere around here.
Right.
And
so
we
you get-
noticed that it was 45 degrees off the bow, but we didn't actually plot anything. And then at 12:16 or 12:46, it was exactly off the beam. So then I'll quickly plot a beam fix. So a beam LOP is super easy because you already have that line, right? You already have your heading line plotted. So you could just draw the line, and then your distance run is equal to distance off.
Bree, do you gain anything if you were to take out your hand bearing compass and you know, do the 45 off of that? Does that give you any more accuracy, or is this just?
Well, at any point, you know, as you're sailing along here and you get an actual bearing of Long Point,
Yeah.
that will for sure make everything more accurate.
Okay. So that puts us in a different category than just.
That's going to put us into running fix. And
gotcha.
now we're going to
Okay.
talk
All right.
about running
Okay.
fix.
All right.
So if we actually get a handheld compass and get a bearing from Long Point, then that would be considered a running fix.
I see. Okay. That's helpful. Thank you.
Okay. So
Bree?
yes.
Sorry, before we move on, and I think it was a question that Jim brought up. The question, does it state that you plot the 12:16 position relative to a 45-degree angle? I'm just trying to visualize the isosceles triangle here. Is it helpful? I don't know, when I saw this problem, I actually made the triangle.
Yes.
So yeah.
You can totally make the triangle. So 45 from here would actually be what, this one? I'm gonna do it on this one. So this is our 12:16 LOP.
There you go.
somewhere along that line at 1216. So you can totally plot that. Again, this is kind of that visual, like we're guessing it's that at 1216. If you had your handheld compass and got an actual bearing, then that would be a little more accurate. So this kind of proves that, you know, this length is equal to this length, but the whole point of this is just to do a quick, you don't have to plot what's in the past, you're just going to plot the most recent fix and then adjust your course from there. So, you know, this comes back to, you know, our, what I want to say, like navigating etiquette. You know, we don't want to have like a bazillion lines all over the chart so that when someone comes to look at it, they're like, what am I even looking at? What are all these lines? We always want to label our lines and, you know, try to keep it as neat and clean as possible. So I don't know. I feel like I'm repeating myself. It's just a quick fix.
So is it fair to say, for accuracy purposes, you're only as accurate as your 45-degree beam estimate?
Absolutely. You're only as accurate as your eyeballs saying that that's about 40.
Could go horribly wrong if you don't have someone thinking.
45, and that's about 90. Yeah. And unless you like, the only thing I could think of is maybe you have like a sextant that you could put on its side and measure from the bow, but that's going to be pretty difficult. And I don't know how accurate you're going to be with that either. This is just meant to be a quick fix.
Can you use a triangle again to get that 45? I just missed that portion.
Yes. So the 45 is going to be using this line or this line. So this was our 90, and our 45 was going to have this line on it, but I flipped the triangle upside down so I could have more of a line. So I put this line here. So let's look at the triangle again. I'm putting this line right here in line with our course because this is a 45-degree angle.
I see. Got it. Makes sense. Thank you.
So I'm putting that in line with my course, and then I'm moving this till it gets to the long point. So again, I didn't actually, the only thing I measured out here was my 115 line, right? I didn't actually measure, I'm just using the triangle to get my 45 and my 90s.
Yeah, that makes sense. Thank you.
Okay, cool. Okay, are we back to the PowerPoint, right? Okay, so we're going to move to the running fix now. So the running fix is a kind of a tricky thing, but we are going to, it's very useful. We can use it in a lot of different aspects. So the running fix is a great tool. So this is technically 2 lines of position that are obtained at different times. So we can go back to last week when we talked about all of our different types of lines of position. You know, it can be that visual, it could be a range, it could be a distance, it can be a sounding fathom. We could use any of those lines of position, but if they're not obtained or observed simultaneously, then they're not, you know, that actual fix. If they're obtained at 2 different times, whether those different times are 2 hours, 1 hour, 6 hours, 10 minutes, 15 minutes, whatever it is, obtained at different times, that is going to be our running fix. So what we're going to do is, it's called advance. We're going to move that earlier LOP. So if we got an LOP at, noon, and we got an LOP at 12:30, but we want to make it a 12:30 fix, we're going to move that noon LOP to where it should be at noon or 12:30, and use and advance that line. So we're going to, on our line, we're going to have it as an advanced LOP. So it's not an LOP at a specific time, it's going to be at an advanced time. You can also retard an LOP if you wanted to, you got some LOPs at different times and you wanted to get like your noon fix. You can, move your 1300 or whatever fix back to noon if you wanted to get a solid noon fix or something for ETAs or fuel consumption or whatever. But in this class, our main focus is going to be advancing the earlier LOP to the time of the second observation. And how we advance that is we again are assuming our course and speed. So we are assuming we're headed in this direction and we are maintaining this speed. So hey, our speed might actually be slower, might actually be faster. That's why the running fix isn't as accurate as if you get LOPs simultaneously at the exact same time. That's going to be your most accurate. But this is when reality hits us and we can't get our LOPs at the exact same time. We wrote it down and then we had to go below, and then I took a smoke break, or I don't know, I got distracted with something, and then a half hour later I got another LOP, or I couldn't see something, maybe it was foggy. There's 100 million reasons why. You can't get it simultaneously. This is our best option, is the running fix. So we are going to assume that our course was the same from one fix to the other, and we are going to assume our speed was the same from one LOP to the other. Okay, so let's talk about how we do it. Again, we're going to start with having that known position and a plotted track line. Hopefully, we're going to get into the habit of plotting anytime we get a fix, whether it's a running fix, a visual fix, whatever it is. If we have a fix, we're going to plot that and then draw our course from it. So we're going to have that DR track line of where, that road that we want to stay on, of where we're going. We're going to plot our first LOP, and then we are going to calculate the distance traveled to the time of the second LOP. So this could be, again, 10 minutes, 45 minutes, an hour, 3 hours, 6 hours, a day, whatever it is. However long you've traveled to the time of the second line of position. So we're going to calculate that distance, and then we mark on our track line that distance it would have traveled. So we're only working from our LOP and our track line, and we're advancing that LOP. We're not going from an aid to navigation or some other point. We're just using the track line and our distance traveled, and we're advancing our line. And we're going to do this so it will make more sense. I know I'm talking here. So we're parallel that LOP back or to the time that it would be. Then we're going to plot our second LOP, the time of the fix, and where those two LOPs intersect is going to be our running fix. So we use an advanced LOP and a time of an LOP, and that's going to be a running fix. Now, when we are plotting where we think this running fix is, we always want to remember that the track line is not an LOP. We went over that last week. Remember, when we get that triangle with the track line, the track line isn't an LOP. It's just the track line. So we want to keep that in mind. Okay, so here's an example from the book, but we will be doing this momentarily, so bear with me. So this tells us I have a track line here and I'm on course 012 at a speed of 12 knots. At 1500, I have a DR, 1520, I have another DR. At 1500, I saw the light E bearing whatever. So I plotted my 1500 position. To advance it, I calculate to 1520. So I can calculate that I'm going to be traveling 4 nautical miles. So along this track line, I am going to mark 4 nautical miles and then parallel that line and plot it again and mark it here as an advanced line. So it says 1500 to 1520. So it's an advanced LOP line. That's going to be our indication that this is an advanced line. It has 2 times. So what they did here, the distance, if I had a little tool, the distance, you know, from here to here is the 4 nautical miles. So I plotted my LOP and then I marked on my track line 4 nautical miles. It hit right there. And then I draw in that parallel line to that original LOP. And that's what I mark as my advanced line. So then I see a stack F. So this is the same, you know, 1500 line here. So it's 1500 from light E. I advanced it 4 miles and this is my advanced LOP line, 1500 to 1520. And then I saw stack F bearing whatever this is bearing. And I plot that at 1520. So I saw stack F at 1520 and I used my advanced LOP to 1520. And where those two intersect is now my 1500 running fix. And then I can plot my course and speed and say, okay, well, now this is my, you know, track line because I have a fix. And now I'm going to plot my track line again. Does this picture make sense of what these lines are? Does anybody have a question of what a line is? Okay. This is another example of a running fix. Okay, so the other cool thing with the running fix is, huge bonus here, you don't need 2 aids to navigation. You know how we talked about we want, when we're creating our fix, we want our aids to navigation to be spread out, you know, that 90 degrees or that 60 degrees. So we have good geometry of where those lines cross, you know, exactly, or a little bit, you know, to create the best triangle. With the running fix, you don't need more than 1 aid to navigation. If you only have 1 aid to navigation, you can use that one and just get an LOP at one time, wait until that angle of that object has a little better spread, and then get another LOP of it, of the same exact aid to navigation. So that's a huge plus. So let's look at this image. So we have a course, we have a track line here. We have a course of 018 and a speed of 12 knots. And then at 1430, I see light G, and I mark my LOP to light G. And then when I'm going to see it again is at 1452. So I'm going to calculate how far I would travel 12 knots in, what is this, 22 minutes. And however far that is, I'm going to mark it on my DR line. So I put a little mark, and then I parallel that 1430 line through that mark that I just did. So I have a paralleled line of 1430 and a 1430 to 1452. So this here is my advanced track line, my advanced LOP, excuse me, my advanced LOP. And then at 1430, I see the light and I plot that LOP. So I have the LOP at 1452 and the advanced LOP, and where those two meet, that is my running fix. And then I can plot my course again to say, okay, this is where I'm going to be now. I'm going to be much closer to shore.
So you updated your position.
Correct.
So you assumed course and speed until you.
Until
Like
I have another fix.
Okay.
This is a running fix.
So the assumed course and speed is only true until you get the next position, and then you change it.
Well, my course and speed is still the same. I haven't actually changed my course and speed, but I have a different starting point. So that DR always has that known starting point, and then we project our course and speed from that. So this didn't show where our known starting point was, but it was somewhere, and this was our course and speed. And then we got a new fix. So we have that new starting point, and we put in our course and speed. So anytime when we plot our DRs, anytime we plot any sort of fix, whether it's a bow and beam, whether it's a running fix, estimated position, visual, whatever it is, we replot our DR line. And what else did I want to say right there? I had something in my head. I guess that was it. Okay, this is another example. This one's a little bit harder to visualize here because it is using range, distance off of a buoy as the advanced LOP, which is, I wish I had the whiteboard to draw on here for you guys, but anyways, so we got a distance off of J at 1440, and that was an LOP. So that's one single LOP. And this was our course line with our DRs. And then we are going to see a light at 1508. So I want to advance this line, this arced distance off my 1440, the distance I would have traveled from 1440 to 1508. So I calculate that time, 60D straight to the distance, and I am going to, in this case, I am going to advance this object, this aid to navigation, in the direction and speed I would have been traveling. So my course was 076 at 15 knots. How long did it take me? 28 minutes, 15 knots, the direction of 076. That's where the buoy would have been if I advanced my buoy. And then I plot that same arc, that same distance off of the buoy. And that's my advanced line. And then I plot my actual 1508 LOP of when I saw the light, and where those two LOPs intersect is now my 1508 running fix. And then we plot our course and speed from there. So let's do one. let's do one and hope it makes a little more sense. So we'll do a new share, get back to our paper. Where are we? We're going to be off the data point. So let me move my camera. Oh, shoot. So start by plotting the position and our course and speed. Bear with me here. Okay. Okay, you guys still hear me? Okay. So for our running fix, I think we made it easy where these two lines intersect. This is our 0800 fix. And we are on a course of 143 at 10 knots. So let's plot that 143. Okay, so I have a course of 143 and a speed of, so you're with me so far, right? And the 2 SJR. So that's going to be that buoy right there. So they have 8 o'clock. We plot our position and we're on a course. At 8:25, we are able to see, so we are going to plot that LOP. So 0, 8.
Hey, are you sure that this is 103?
What was the question?
Are you sure that you plotted 103? It doesn't look like 103.
143.
Oh, sorry, 143. Yeah, sure. My mistake.
Yeah. Thank you, though. That's a good. You got to call me out. So this line is our 0.825. I'm somewhere along that line at 0.825, but I don't have another piece of information. I'm gonna throw something else in here for you. We're gonna talk about estimated position. Remember, our estimated position is when we have one piece of information, like one LOP. That's what this is, right? We only have one LOP. So I'm gonna plot my DR for 825. So we'll plot 0825 DR. So if I have my distance equals speed times time over 60, my speed was 10 knots, my time was 25 minutes. .16. Okay, I'm going a little bit off book here, but I think this will help. So I'm going to plot my 825 DR position. So again, it's from a known position for 1. Oh. I was hoping it wouldn't be as accurate as it is. Let's just say here, now I know I'm going off book a little bit here. Let's just say this was our 0825 DR. So we had a DR position and one LOP. So where we would put our estimated position is wherever along, I know I'm somewhere along this line, and this is my DR. So wherever along this line is closest to this DR. And how we do that is by using that 90, or you could, and I'm going to say right here would be my EP, or my estimated position. Because this is the closest point on this LOP, right? Infinite possibilities along this LOP. And the closest point on this LOP to my DR, my calculated position, is going to be my estimated position. That's what I'm going to call an EP. I know I didn't go over the EP on the PowerPoint, but I just wanted to throw that out there before we plot our other line. Maybe you shouldn't have. That was probably confusing. I'm throwing information at you.
But if you're assuming course and speed, why would your estimated position would be naturally where those two lines intersect, wouldn't they?
No, I'm assuming my speed is 10 knots. So this would be my distance I would have traveled at 10 knots. So if I'm further along my track line, that would be assuming that I'm going faster. So it's wherever you know you're somewhere along this line, that we know. So wherever this line is closest to your DR, that is your estimated position. Not where not where your track line intersects. Your track line is not an LOP. So the estimated position just has one piece of information. So it's not this like intersection thing that we go with all the other types of fixes.
So in this case, the shortest distance would be a straight line. Therefore, this is why you did that 90 degree line.
I do the 90 degree line because that's, for me, that's the easiest way to get the shortest possible distance. So you could use your dividers and say, you know, if I make an arc, where am I going to get that tangent arc to get a shortest possible distance? It's going to be a perpendicular line. So that's kind of just like a shortcut way of getting, a quick way of getting it. It's going to be perpendicular to this LOP line. To your DR is how you get the closest possible point on this line to this point. It's going to be a perpendicular line, or you could do, you know, the arc with a tangent if you want.
Thank you.
Okay. Let's go back to running fix because that's what the lesson is on. I'm sorry. Told myself I wasn't going to get distracted this week. Okay. So this was at 8:25. Then we saw the same buoy again. We have patchy fog, so we see the light. We don't see the light. We see the light again at 8:43, bearing 030. So I want to plot that LOP now. So I'm going to plot 030. I'm going to have to move this one. Okay, so I had an LOP at 8:25 and an LOP at 8:43. So in order to get a fix along this line, a running fix, I need to advance this line. So I need to advance. Now, how much am I going to advance it? I am going to advance it 0843 to 0825. What's my time difference there? 43 minus 25.
18.
18 minutes. So I have my time is going to be 18 minutes. So I can do my 60D street. How far would I have traveled? Assuming my speed and my time. 10 times 18 divided by 60. Distance equals 3 nautical miles. Oh my gosh, I'm not even doing it here. So my distance that I want to advance this line, so I want to advance this line 3 nautical miles. So I'm going to find 3 nautical miles. This is the distance I want to move this line. So this point right here, where this line interacts, touches my DR, that is going to be where I move my 3 nautical miles. Draw this here. It's 3 nautical miles. So I've just made a little mark on my on my track line here of where, if I were to advance this 3 nautical miles. So now we're going to parallel this line. So I'm going to put using the triangle. You can do it using any other tool, but here's using the triangle. I'm going to put my LOP on the long side. And then I'm going to move it, parallel it, till it hits this point that I've just created. And I can draw in my parallel line. So this is 0825 to 0843. That's an advanced line. I advanced it along my track line by 3 nautical miles. So where these 2 LOPs meet, right here, that is my R fix, my 843 R fix. So essentially, I kind of like to draw it this way too, is we saw the light at 825, and then we're advancing it, basically meaning we're moving that light, our course and speed, by 18 minutes. So our course, what was our course? Oops. 143. So if my course was 143, in 18 minutes, that buoy would have been right here. And I get my LOP from it. So I'm essentially moving, creating this fictional buoy here and a buoy here, so I can get this fix. Even though that buoy is not there, I just advanced it along with me. All right, so talk to me, guys. How are you feeling about this running fix thing?
Bree, can I ask you?
Oh, okay.
No, after you, please.
I have more kind of theoretical question.
Yeah.
By doing this, we are assuming that our kind of speed is more accurate than our direction. Yeah, because we are using our speed in calculation, and
it does work that way, yes.
But in real life, from your experience, what is easier to kind of maintain, speed or direction?
I want to say they both have, I don't know, their places. I want to say it depends on what kind of instrument you have on board measuring your speed. Is it averaging your speed in the last 5 minutes? Is it averaging your speed in the last half hour? Typically it's going to either give you an instant speed through the water or kind of this average speed over the last 6 minutes, 10 minutes, half hour, whatever it is. So I'm going to say that tends to vary on your how accurate your speed actually is. But if you look at it, you can say, like, if my speed is slightly slower or slightly faster, my actual speed, how is that going to affect my position? I might end up, you know, closer to my track line if I was slower, or further away from my track line if I was going faster. So you might say, well, like, this is my running fix, but maybe accurate. Any other questions? Arette, what was your question?
Sorry, Bree, I don't know if that was me, but you were kind of silent, maybe even frozen for the past 5 seconds. 5 to 10 seconds.
Yes.
All right.
All right, am I still there now?
It makes
Can you hear
sense.
me?
Yeah, thank you.
Okay. Any other questions?
Bree, I had a question.
Yeah, go ahead.
So when I first saw this, I looked into try to invest into like a laser distance meter, but like the cheapest one is like 20, 40 bucks, and it only goes through at 300 meters. But they're
To
not
measure
that.
distance off of something?
I was literally thinking about a fog situation, and I was thinking like, hey, can this be done? And I'm not sure. It depends on what you're using as your reference point. But I had a question in your chart because mine was a little off, definitely. You used a aid with your track line to the first LOP, that 90 degree. I think my RFX is definitely off. Can you go over this aid one more time, the 90 degree angle? I think that's where I probably messed up.
The 90 degree angle? Oh, the EP?
Yeah, the EP, please. Could you go over that? Because I think I didn't. Yeah, I didn't do that. I didn't do that
Yes,
at all.
I just threw this EP in here to confuse you. I did not mean to. I should have just kept my mouth shut. I just added in what an EP is.
So I got to the right of my track line, but I was way more off than you are. So I'm not sure why.
So the EP shouldn't have affected your actual running fix. So let's just create an example here. Here's my track line. I'm on course 060 at a speed of 10 knots. I'm just making up an example here.
Mm-hmm.
So here's my coastline. I'm gonna plot okay, so this was at, what is it? It's 10 o'clock, 8 o'clock right now, 2100. So I'm gonna put a DR out here for 2100 because we're gonna do on top of the hours. So at 9 o'clock, I think I'm going to be there. And I actually get an LOP that says I am from, here's light. I get an LOP at 2100 that says I'm right there. So how do I use these two pieces of information? Sorry. how do I use these two information to get an estimated position? I have one LOP and then I have a DR. So I know from this LOP, I'm going to be somewhere along this line. Infinite possibilities along this LOP line. That's what an LOP is. So I'm going to use where I thought I would be at 2100 and say, okay, this is where I think I would have been, but this is my actual LOP. So what is my closest possible point along this line to my DR?
Oh, gotcha.
So that is going to be right here.
EP.
And that we make a square and we call it an EP.
An estimated position.
So how I figured that line was I went 90 degrees from my LOP line to my DR. Let's make my DR a little bit bigger. That makes sense. So I'm combining the DR information and the LOP information, and I'm saying let's put those as close together as possible and call it an EP. Now, when I tried to explain that here on the chart, I did a bad job of it. I'm sorry. Why does this look weird? There we go. Okay. So my actual DR, if you calculate it out, is pretty much where this line crosses my track line. So I just made it up and said my DR is before it. So this thing that I did should have no effect on where your running fix ends up. All right. It is 8 o'clock, so let's take a 10-minute break. Think about these things. Let me know if you have any questions. I know these are both kind of concepts that we're wrapping our head around here. And then when we come back, we'll touch on danger bearings, and then we're going to dive into assignment 14, which will have an example of a bow and beam and a running fix, and some other fixes that we're going to practice. All right, so let's come back at 8:10. We'll do 10 minutes.
Bree, is the course outline for Coastal Navigation 2 building on what we learned here in Coastal Navigation 1, or is it more practice and additional experience with, can you give us a little bit insight on what Coastal Navigation, what the course outline is going to be like?
Yes. I will bring it up here for you. Am I on? Make sure I'm not on mute here. Can you hear me? Yes. Okay. Sorry. The skills that we are learning here, the plotting skills, you're definitely going to be using, but we're going to kind of move forward a little bit. So I will bring it up. And next Wednesday, for those of you who have signed up, I send out the email and the link to Coastal Nav 2 Google Classroom. So you guys will be getting that email next Wednesday. But here is the outline of what we're doing for Coastal Nav 2. We talk about kind of vocab and what we're talking about when we talk about set and drift in week 1, and we talk about the vector triangle. That's where we're going to use those radar plotting sheets to practice the vector triangle, and that's, you only really need like 2 or 3 sheets, and it's really just like practicing that concept. And then in week 2, we're going to do like a full chart plot exercise using the concepts of the vector triangle with set and drift. So you're still going to need those, you know, how do you plot a fix? How do you plot DR, 60D Street? You know, all these skills that we've learned in Coastal Nav 1, we're going to put into Coastal Nav 2. So it does kind of leap from what we've learned this class. And we're going to calculate tide by hand. Week 3, that is a old thing that people don't do anymore, but if you are getting the U.S. sailing coastal navigation endorsement or U.S. Coast Guard endorsement, you need to know how to calculate by hand. So we're going to go over how to do that. And then the last week we go over kind of electronic navigation systems. Just kind of the basics behind it, and some really just like vocab of what these letters and numbers mean on your GPS, depending on how advanced your guys' GPS is. So so it's just 4 weeks, not as much information. It's mostly tides and currents, set and drift, but yeah, that'll start right after this class. No break this time. So cool.
Do you know by when we're going to lose access to the Google Classroom for Coastal Nav 1?
Yes, so for Coastal Nav 1, you'll lose access to it when I have my next Coastal Nav 1. So that is going to be April 14th. So I send out and update the email on the Wednesday before. So April 7th, you guys will lose the Google Classroom. But all of my videos are on YouTube, so you can access those videos at any time. And you can download all of the assignments. Hopefully you already have the paper copy of the assignments. But yes, the Google Classroom goes to the next set of students, which will start on April 14th for this class.
Bree, you mentioned the U.S. sailing certificate, coastal navigation certification. Can you tell us a little bit about it? I mean, obviously, I'm sure you're going to go into more detail in the second class, but is the class or is the certification or exam kind of whenever, or are there fixed days, or can you tell us a little bit?
So I actually can't give you that exam because I am not endorsed by the U.S. Sailing.
Okay.
So you make an appointment with the front office at OCC, and they'll have you come in and take the test in the library, essentially. But everything that is on the test is what we're learning in these 2 classes. So taking Coastal Nav 1 and 2 are going to prepare you for that test. And I don't know if it's like 70% pass. I don't really know how many questions it is, but the front desk will have that information. And yeah, if you complete these 2 classes, you can take the test if you want that certificate. I don't know exactly, you know, why you're getting the certificate or not, but sometimes just printing out, just getting a printout or PDF from the front desk of your basically the attendance sheet that says, or your transcript, that's what they call it. The transcript at the Seamanship Center is can give proof that you've taken this course if you're trying to give it to your insurance or whatever you're getting it for. Sometimes just the transcript will work for that. So check that out. All right. Let's get back to it. Any lingering questions on bow beam or running fix? Okay.
Yeah, Brady, I just had one real quick question. So on the running fix, if you have a fathometer, would it be a good idea to kind of check your depth at that same point too, just as kind of a third reference point?
Definitely. The more, you know, data points, LOPs you can get, the more accurate your position will be, for sure.
Right.
Okay. Share screen. Okay, so we're going to talk real quick here on what a danger bearing is. So this isn't a fix or anything. It's just something that we want, if there is a danger that we want to avoid, we can use this danger bearing as a quick way to say, hey, I'm in the clear, or hey, I need to actually figure out where I am and adjust course if I need to. So essentially what a danger bearing is a quick way to keep clear of a danger, whether it's a wreck, a shoal, anything really. And how you draw this or create it is by drawing a line between two objects. So these are going to be objects on the chart. It doesn't have anything to do of, you know, your position of where you are. So you could do this danger bearing way ahead of time, you know, way in your voyage planning. So one of the objects is going to be your danger, and one of the objects is going to be, am I frozen again?
No.
Anyways, one of your objects is going to be something that's easily visible. So whether it's the point of the jetty or the big lighthouse or that buoy, that safe water mark, just something that you can easily see visually and is on the chart, obviously on the chart. And in the general direction of what your heading is. So not like completely behind you, because then that loses the point of it. And then we're going to label not less than, but not more than. And I'm going to show you an example here of what that means, because that's kind of hard to point out. Okay. Where's my marker? Okay, so let's say here's a lighthouse, and here's a wreck, some rocks, shoal area that we don't want to, that we don't want to hit. So as we are cruising along, we want to make sure that we don't hit this danger. And how we're going to plot this is with a danger bearing. So I'm going to plot a line from a fixed object that I can see on land, so that's going to be the light, to the danger in general. So let's call that, maybe we'll do both lines here. So maybe we'll make this a little more visually easier to read. Sorry, let's do a straight line across the page. Okay, so this is 090. So we'll call this a little bit less, 080 degrees. So I am drawing a line from my danger to the fixed object. So if I'm cruising along here and I see that object and I'm in the clear, in this great area, the bearing to that object is going to be maybe 060 as I'm cruising along. It's going to be small. So this is going to be a not more than, we'll do 080. So if at any point I get a bearing from this light or to this light that is more than 80 degrees, that means I'm up here. So from here, the bearing to this light is maybe 100 degrees. That doesn't mean I'm running aground. I am, you know, need to start abandoning ship or something. It just means I could be on track to running into this danger that I don't want to be. So if I have a bearing to this light that is anything more than 080, I could be in, you know, this area, essentially, this whole area. If anything is less than 080, if anything is or more than, that puts me in this danger zone. If I am over here, my bearing to that light is going to be less than. It's going to be giving me in a clear zone. You know, 045, whatever it is. It's going to be less than whatever I've created for my danger line. Does that make sense for a danger bearing? Okay, now I'm gonna, so this was a not more than. Let's do a not less than. See how that looks. So here's the coast. Here's our light. And we got some shallows that are coming out. This way. That we want to make sure we don't, oops, we don't hit this shallow little reef here. So I am going to get a line going from my light, or from my, light that I can see, maybe it's the end of a jetty or whatever, to the danger. So this danger is maybe submerged, maybe it's not submerged, wherever it is, but it's plotted on the chart. So I'm going to say, okay, here is my danger line. I don't want to be in this area, right? I don't want to be in, so if it's up here, if it's up here, wherever it is, this is my no-go zone that I am creating as a navigator. So as I'm cruising along here, so this bearing, we'll call it 020 degrees true. So I want nothing less than 020. So if I am over here in my safe area, maybe I have 030. Maybe I have 040. 4, 5, whatever. Anything more than 0, 2, 0 is going to give me clear. Anything less than, so 0, 0, 0, right? If it's dead ahead of me, then I'm in a danger zone. I'm in a no-go zone that I have created. So it doesn't mean, like, I could be this bearing, right? I could be way down here and not even in the danger. But it's just saying, hey, I have a bearing of less than 0, 2, 0 to this object. I have that marked as a danger bearing. I want to make sure I know exactly where I am. And if I need to alter course, I make those adjustments. So again, this isn't like an actual plotting thing. This is just something to keep in your head with all the million other things that you're keeping in your head as you're navigating. Any questions with our danger bearings? I know that was a quick little explanation. Okay. Let's bring out assignment 14. I am going to switch to a more reliable internet real quick. So I might leave, but I will be right back. Stop share. What the heck? All right, I think that will work. Okay, so we're on this guy. Okay, so assignment 14. This is our advanced cruise along the California coast. So we are cruising along California, and let's see. Oh, we start with a notice to mariners correction. So we start with checking our local notice to mariners, and we see that they're reporting a new lighthouse. So again, this is just for training purposes, but we have done our voyage plan and checked our notice to mariners, and we have a new lighthouse. So we want to plot that. So let's do a quick plot now that we are expert plotters, right? What do we have? We have 33 degrees, 32.9. So 30. 32.9. And 48.3. So right where that 2 rock point is, we are putting in our new light. All right, so there's my new light. And then it tells us, continuing on, we plot our new light, and then it says we plan to leave Newport Beach, the NWP buoy at 0800 and cruise on a course of 120 PSC towards Dana Point at a speed of 5.2. So let's plot our position and plot our DRs. So we are going to be leaving this NWP buoy. So this is our starting point at 0800. But I want to plot my course, and they give me a compass course. So I am going to use my TVMDC. My compass heading is 120 degrees. So I need to work it this way. So this direction, I'm going to be adding east, subtracting west. We're remembering this from a couple weeks back. So our deviation, we're going to go to our deviation table. I had a ruler somewhere. There's a ruler. Okay. We had a compass heading of 120. So we have a deviation of 4 degrees east. I'm going to be adding that. And I get 124 degrees magnetic. And then I look at my compass rose, right? This is where we get our variation. Right here, we have 12 east. And again, it's east, so I will be adding that. So I have a 124 plus 12 gives me a true of 136 degrees true. So now I can plot my course and DRs. So we have a true course of 136. So there's my course line of 136 at a speed of 5.2, right? Yes, 5.2. And it is asking us for our DR position of when we are going to be a beam of 2 rock point light. That's the new light that we've just created. So a beam, that's going to be a vocab word for us. So that means 90 degrees, right? So we can use our triangle with our 90. Triangle. There we go. You can see it a little better. So I'm going to put my pencil on my 2 rock point and use that 90 to see when I'm going to be a beam of it. And that is going to be a beam position. Now I want to figure out what time that is. So I'm kind of working this DR a little bit backwards, if you will, because I have a distance and I want to calculate what the time is, because my desired DR is a beam position, not an exact time. So let's figure out what this distance is. What distance did you guys get? Let's see.
4.1 knots.
4.1. So my distance is 4.1. My speed is 5.2. What is my time? Let's do the old magic circle. So we multiply and then divide. And what time do we get?
47 minutes.
47 minutes. So my time to this, my DR time would be 08:47. Okay. So that was just a compass error exercise and a 60D street exercise. We got that. But a little bit earlier, so now we're kind of going back in time here. At 8:38, you take your first fix. The NWP buoy is bearing 313 true, and the 2 rock light is bearing 065. So we have 2 LOPs at the exact same time. So this is going to give us a visual fix. So we have NWP at 313 and 2 rock point at 065 degrees true. So these are both in true, so I don't have to convert, which is great. But I need to plot these 2 visual bearings that I got at the exact same time and see what my position is. So let's plot our NWP. Here's our NWP, and it was bearing 313. You see that? Yep. There's 313. So here's an LOP. And then my new light, using that as an aid to navigation, it was bearing, so you can see, 065. So I have a new fix here. For me, it's right on that 35 sounding. And that was at 0838. See my plot here. Uh-oh. Okay, so we had two LOPs at the exact same time. And then they ask us some questions about this. They ask us, what was our actual course over ground and what was our actual speed over ground? So if I left this buoy at 8, and then this was the next fix that I got, what was my actual speed over ground and course over ground? So I'm going to measure this course. So my course was 133. We'll call that. 133 was my course over ground. And my speed over ground, I need to go back to my 60D street here. So my distance, I'm looking for speed, and my time was 38 minutes. What was my distance? Oh, here it is. So from my 838, let's see, I got 3.8. 0.8 nautical miles. And I used my 60D street. What speed did you guys get?
Bree, you're moving pretty fast through this to try.
Okay. Thank you. Thank you for telling me. Don't have my calculator yet.
Something like 6 knots.
Yes. So that was.
I got 6 knots.
3.8 divided by 38 gives us 6. Yep. So 6 knots is our speed over ground. So we plotted our DR, but it wasn't for the time that we plotted anyways. But we had our, so when we pass close to an aid to navigation, we can call that a fix. So we passed very close to this NWP buoy and headed in my course of 136 true. Over the past 38 minutes, because I just plotted a position, I know that my actual course over ground was 133 and my speed over ground was 6 knots. So I'm going a little bit faster and I'm drifting a little bit closer to shore. So it asks us, Why are we not on our original track line? Well, it could be lots of things. It could be wind and current. It could be, steering error. We could, not be holding a steady course as we thought we would. Set and drift, all sorts of different things. But that's the way it always goes. That we're not exactly on our track line. So this is our 838 fix. You can plot the lat and long. So this was our 0838. So our next part of the assignment here says fog starts rolling in. After we plot our 838 fix, you decide to steer a course of 140 PSC, continue at our same speed, so we can move a little bit further from shore. You're still concerned about your position, so at 8:56, with a little luck, you observe the hospital, use your 838 LOP to plot a running fix. So this is going to be our running fix example. So we have decided that we have been drifting closer to shore, so we are changing course. So we've changed course to 140 degrees PSC. So in order to plot that change of course, so we have a known position, our 838, but we want to plot our course change. So we need to convert this back to true. So we can do our TVMDC 140 PSC. Going this way, we're adding east, subtracting west. So we go to the deviation table, 140 is going to give us a deviation of 2 east. We're going to be adding that east. So we get 142 degrees magnetic. And then we look on the chart for variation. We get that 12 east. So we're going to add that. And we get 154 true. So now I can plot that course change. I'm going to put my pencil on my known position. And I'm looking for 154. There's 154. Saying this is now my course line. So I can I had my eraser, I could clean up this. I don't know my eraser. Okay. There's another one. could erase this line. And I have a new course of 154 degrees true and my same speed of 5.2 for this new course line. Then they told me I want to plot a running fix. So I'm going to use that 838 line. And whenever I see the hospital at South Laguna. So here is the South Laguna Hospital right there. And this bearing I have as PSC. So I need to change it. So this was my heading. And my bearing to the hospital is 103 degrees PSC. So I need to convert that to true so I can plot that bearing. So with our deviation table, we always go off of our heading. Remember the heading. So our heading is still the same as our calculation for 140 heading. So our deviation is still 2 degrees east. So that gives us 105. And then we have a 12 degrees variation. We're going to add that. So we have a bearing of 117 degrees true.
So why is our deviation still 2 degrees?
Because deviation is based off of heading, not bearing.
Okay.
Our heading is still the same.
Okay.
So I'm going to plot that 117 South Laguna. So this was at, what time was this? 0856 is this LOP from my South Laguna Hospital. And then I want to advance this line. So we're going to advance my 838 to 856. So let's do that. We're going to go from 856 and 838. What is our time difference? $18 minutes. Is that right? 56 minus 38. 18. So I want to then convert that to my 5 point with my time, 18 minutes. Speed was 5.2. What is my distance?
1.56.
156.
what was it?
156.
156.
Yes.
That makes sense. Okay. So my 838 is where this line began. So I'm going to find my 1.56 miles. And I'm going to advance this line. Let's see. So it's starting at the beginning of my new track line here. And then I'm going to advance it 1.56 miles. So this distance is 1.5. So I'm going to parallel this. Down until it crosses this line. And this is now my 838 to 856. This is now an advanced line to 856. And this is an 856 line. So this would be my R fix for 850. So talk to me, guys. How does yours look?
Pretty close.
Mine's on the map these days, on the chart.
All right, all right.
I used my chart for some real, when I was actually setting data points. So I've got too many lines. I got to get a new chart.
Yes, it gets very confusing when you have too many lines.
Chart for
so
adventure.
From this, I can see that I'm still getting pushed closer and closer to shore. So I got pushed closer to shore here, and I adjusted course, and I'm still getting pushed closer to shore. So maybe the wind's picking up. Something's happening. I'm still getting pushed closer to shore. So that's what I can see from this page. So I am going to turn the page here. And it says for my 856 R fix, I don't think. What does your guys' say? I know I've edited this. Does it just say at 8:20 or at 9:20 at you change course? Hold on a second. At 9:28, you decide to head further offshore and steady on a course of 160 PSC. You decide to take a bow and beam fix and see Dana Point building or a bow and beam fix. Okay. I'm just curious. Does your guys' assignment that they printed for you have a little sentence that says you've drifted at a speed of 1.7 with a set of 133? Or no? It shouldn't say that.
No.
Okay, good.
Mine doesn't.
It starts with from your 856 R fix. You drift while deciding what to do and decide to change course.
Okay, okay. I have just a out of date thing. I want to make sure I have what you guys have. So it tells us we want to change course to 160 PSC, right? So we're coming to the right, another 20 degrees. So we go back to we're changing course again to 160 PSC. So we go back to 160. We're going this way. We're adding east, subtracting west. So we need to convert to true so we can plot it. 160 is going to give us a deviation of 0. So we have the same 160. And then we have a variation of 12 east. We're going to be adding that east, and we get a true of 172 degrees true. So from our 856, we're going to plot 172. So here's our 856. And now we're going 172 from our 856 position. So I'm going to erase this line.
So you've been drifting for 34 minutes then. Is that right?
Yes, we have.
So that position that we had may no longer be our position, but we just have to go with it.
But we're just going with it, yes. And we are going to get a bow and beam fix from this building. So I know I've been drifting, I've changed course, I'm almost headed due south, and I need to get a quick fix to figure out if this is helping me at all. So I'm going to see this building and get a bow and beam fix from this building. So they told us for our bow and beam fix, we see the building. So they are explaining it. We see the building bearing 315 degrees relative to our PSC course. But we know our true course. So we see the bow bearing at, does it give us the time? What? Oh, it's telling us the bow time is 09:28. And the beam time is 10. This is a very poorly phrased question. I'm going to have to clean this up. So we're still on our course of 160 degrees PSC, which is our 172 degrees true. And we have our two bow and beam fixes, or times. Oh, and our speed is still 5.2. So with our bow and beam line, we already have our track line plotted. So I'm going to do a beam line, so that 90 degrees to the track line of when it hits the building. So when does it hit the building? If I'm a beam of the building and this is my heading, I'm somewhere along this line. But now I want to use distance off as an LOP. So I'm going to use these 2 times to get my distance off. I'm looking for distance and my time. My time is going to be 32 minutes. So I have my speed,
2.8.
my distance, what do you guys?
Yeah, 2.8 knots. 2.77.
Distance, nautical miles,
Right.
right? So we have our
Yep.
5.2 times 32 divided by 60 gives us distance. So 2.8 is our distance traveled. Our distance traveled between these 2 times. And that will be the same as our distance off. So we'll get 2.8. From the building, that was our distance off. So we have our bow and beam fix for 10 o'clock. Along our beam line, this is just that 90-degree line from our heading. And then the distance off was using this 60D street method. So I really don't like how this question is phrased. But does that make sense for my bow and beam? I didn't plot the other stuff because it wasn't quite accurate or anything. I just plot my beam bearing and then my distance off. And it's asking us a way to check our position. Which fathom curves are we in between? So this is an exercise of finding those fathom curves. We are not along our track line. We are closer to shore. So we're in between the 200 and 250 fathom lines. Okay. So our next part of the assignment, instead of keeping traveling or changing course to the right, We are now going to come left and go into Dana Point. So 25 minutes later, we get a fix. Gonna move this down a little bit. So at 10:25, we see a visual range. So we see two things in line. So in line, we see the 2 SJR and the cross. And then we also see, oh, nope, sorry. Two SJR and the building. And then we see the cross bearing 038 degrees PSC. But we did have a course change. So we're adding in here our 10 o'clock course change. We came around to 100 PSC. So let's plot that line. So I'm not going to touch this just yet, but I want to plot my my track line because I have a course change. So we replot our track line anytime we have a course change. So T, V, M, D, C. We're getting real good at our compass error, right? 100. Oops. So we get a deviation of 5 east. We're going to add that. $105, then we get our 12 east variation, which we'll add. And we get 117 degrees true as our true course. So let's draw in our true. There we go. So this is our 117 degrees true track line headed back into Dana Point. At 10:25, we see two things in line. So this is one LOP, and then this is going to be another LOP. So let's plot the in line is the buoy and the building. So that's this building and this buoy. So as I'm traveling, I see these two things come in line. So I will plot an LOP for 10:25. If those two, if this building and that buoy are in line, I'm somewhere along this line. And then I also got a bearing to this cross. the cross was bearing, we'll use this because I already have it. So this was my heading. My bearing to the cross was 038 degrees PSC. So again, our deviation goes with heading. So our deviation is 5 east. This was a bearing to the cross, not a heading. So our heading was still 0, 0, 0 or 1, 0, 0. So we're using the 5 east as our deviation. We'll add that. So we get 0, 4, 3. Then we have 12 degrees east. So we'll add that. And we get 5, 5, 0. So 0, 5, 5 true is our bearing to the cross. So here's our cross. And let's see. Let's find 5, 5. I'm going to extend this line real quick. There's my cross. 5, 5. So this was bearing 0, 5, 5, and this was in line. So that means I am real close to that buoy, and that is my 1025 position.
So Bree, what, I thought you didn't account for deviation whenever you're using a bearing from a hand compass.
So, yes, this one gave it to us in PSC instead of M. So when you
Okay,
look
so you're
at
taking it off the ship's compass.
yes, so when you look at the unit of measurement, it's saying it's off the ship's compass. If it's in M, then you don't use the degrees M, then you don't use the deviation.
Okay, got it. Thanks.
Okay. Last little section. This is the never-ending example here. Last little section. What was our actual speed over ground since 10 o'clock? So here was my 10 and here is my 1025. So how far did we travel? I got a distance of exactly 3. So I have a distance of 3, a time of 25 minutes. That was from 10 to 10:25. And I'm looking for what my actual speed was. So I have 60 D divided by T gives me speed. 63 divided by 25 gives me
7.2 knots.
What was it? 11?
7.2 knots.
7.2. So my actual speed was 7.2 on my speed over ground. Okay. Closer here. So that was a good review, I think, of all of the things that we've been practicing. So our next assignment is going to be our final. So this probably looks somewhat familiar, kind of like what our week 1 homework was, right? Our week 2 homework. And then we do an actual plot, practicing these 3-point fixes, practicing the running fix, practicing the bow and beam. All these types of fixes we're going to practice on the training chart. So that is our final assessment, our final review of what we've learned in this class. The video of me doing it is posted on the Google Classroom YouTube. So please review it so you can check your answers. If you have questions or you get stuck, email me and I'm happy to put the document cam out and do another little Zoom for you guys during the weekend or whenever you guys are working on it. So feel free to reach out, or we can just go over it next week in class. If you guys come up with any topics you want to go over besides set and drift and current, because we'll be doing that in CoNav1, we can go over some stuff next week. But I really don't have any new information I'll be going over. We've kind of covered what we're going to cover in CoNav1. So I know today was a lot. We kind of went over the rest of the types of fixes. Kind of abstract to get your head around sometimes, but yeah, let me know how you guys are doing. Also, if you guys don't come next week, that's totally fine because there's no new information. But I did want to show you on the Google Classroom. Oops. Google Classroom 2. I do have a online class evaluation form. So this one is for me, just so I am trying to refine this class. As you can tell, there are some things I want to edit along the way, but each time I do it, I think it gets better and better. So I really value your feedback. So please let me know what you guys think of the class. You guys can do it next week, but if you guys don't come next week, that's fine too. Because we don't have any new information and I've posted the videos online. So I get it if you guys don't want to come. But yeah, do you guys have any questions?
How do we submit those evaluation forms to you?
So you just click on it and it's an online survey thing. At the bottom, it'll just say next, next, and submit. So it's an online form.
Thanks. I was thinking it was a PDF.
Yeah. All right. Well, thank you guys. And remember to email me or text me or shoot me some topics that you guys want to go over. I'll come up with a few just so I can start talking at you guys, but you guys are probably tired of me blabbing on. So yeah, I'll see you guys next week.
Great, thanks, Bree.
Thank you.
Thank you.
Thanks,
Yeah.
Bree.